passed, then you have no homework. You should. If you don't get the checkpoint passed, then your homework would be to finish the checkpoint. Okay, everyone has their number stripped because Daniel's awesome? Awesome. We'll give him a point for passing those out. Let's start on number 4. Anyone volunteer before I let him handle it? Yes, Ellie.
18x negative 2x plus 1.
Perfect. That's exactly how I would have done it. However, it's going to be okay if you did. Now, we got into a debate last period, not about the 18. They agree, well, I guess about the 18. They were like, but Miss Compton, 6 goes into 36 and 18. That's true. 9 goes into 36 and 18. That's true. We're wanting the biggest number that goes into both, and the biggest number that goes into both is 18. If you factor out an 18x, you could always distribute and check yourself. 18 times negative 2 is negative 36. X times x, x squared. 18x times 1 is 18x. So I know Ellie's correct. And her group gets a point for that. Number 5 involves some exponents. Yes, Jax?
8x cubed, 6, or x, 6.
Okay.
Plus 2x minus 1.
Okay, and that seems correct, but again, we could check him and make sure. We distributed 8x to the third, 3 plus 6 is 9, so 8x to the ninth would be, yes, he's right on that. 8 times 2 is 16, x to the third plus x to the 1 is x to the fourth, he's correct on that. That last term, 8x to the third times negative 1 is negative 8x to the third, perfect. He did a great job, his group can have a point. Okay, and then last but not least, we've got number 6. Y'all ain't got none of these. You do? Okay, well, Daniel's been dying, so let's let Daniel go. Because Ellie's gone and Jackson's gone. We'll let Daniel go. I was hoping Nick or Paige would save the day, but apparently not. So, Daniel, go ahead.
5x.
Okay?
X squared, y squared plus 2xy plus 5.
That sounds correct, but again, I can check it by distributing to make sure he's not crazy. So, 5x to the 1, x to the 2 is x to the third, y squared. So 5x to the third, y squared, he's right on that term. 5 times 2 is 10, x times x, x squared, and a y, 10x squared y, he's right on the middle term. And then last, 5x times 5 is 25x. So he is not crazy, he is completely correct, and his group can have a point. If your group is trying to get ahead and get all the points, we're doing 7 through 12 tomorrow, it would be genius of you to go ahead and get those done.
At this time, anybody who has not had their pictures done, 9th through 12th, and faculty,
I am not this
if
patient.
you have a retake or a makeup, please make your way to the lobby at this time.
I am not this patient.
9th through
I'm not this
12th,
patient.
faculty,
I'm not this patient. I'm
please
not.
make your way
I'm
to
not
the
this
main
patient.
lobby for a retake.
Don't
Thank
have
you.
this patient.
Last call.
I'm not this patient.
Retake pictures.
Since when did they say it 5 bajillion times? It's not picture day. I'm telling you, I need to take off picture day specifically. I have no idea. Do you think I listen when they talk about pictures? No. No, I don't. Honestly, I don't listen when they talk about pictures. Where did my giant packet go? Don't you hate it when that happens? Okay, so you got your giant packet. Now it's find mine. That was my first grade one. It's my first grade one. Bless his heart. Okay, so where did you go, giant packet? Somewhere in the, oh, here you are. Okay, in the abyss. So we're on page 37 in the giant packet. These notes are not going to take long. So the good news is Nick bombed piecewise, but he's going to get it together because this section's really easy, so it's going to give him a little hope. So piecewise was hard. Let's do an easy section, rebuild our confidence, and then go back to some more moderate stuff. So today is an easy day. So we're going to talk about graphing linear inequalities. So I'm going to need to change that to and for being proper in English. And inequality resembles a linear equation but with an inequality symbol instead of an equal symbol. What are the 4 different symbols you could see with an inequality? And Ellie got all 4 out first. She can have the point. So yes, less than, greater than, less than, equal to, greater than, equal to. So that's what we're dealing with today. So we're going to graph inequalities. Now that sounds daunting, like piecewise graphing daunting, but it's actually really easy, even easier than piecewise. We're going to graph it just like it was in y equals mx plus b. In our mind, when we graph it, we're going to pretend like it's an equal to sign. So for this first one, I'm graphing the line negative 3x minus 2. So I literally put my intercept at negative 2. And the hardest part of today's notes is it's impossible to read these numbers, so you just have to count 1, 2. So I put my intercept at negative 2 on the y-axis, because that is my b. So I put my point at negative 2. And then my slope is really 3 over 1. So I'm going to go up 3, and then to the left 1, up 3, and then to the left 1. 1, 2, 3. 1, 2, 3. And I can go down 3, right 1, down 3, 1, 2, 3, right 1. And it's looking pretty good. If I can count. 1, 2, 3. Okay. So it's looking pretty good. However, now we got to get to the inequality part. So we graphed the line easy. Are there any questions about graphing this? Okay, here's the fun part. If it is a less than or a greater than, we are going to use a dotted line. If we're using less than, equal to, greater than, equal to, we're going to use a solid line. So it kind of reminds me of what we just did with piecewise when we had open circle, closed circle, and that signified something. In the same way with our graph, if we connect all the dots, that implies it's a less than or equal to or greater than or equal to. Whereas if we use a dotted line, it implies our problem was a less than or a greater than problem. Okay, but our problem was greater than or equal to, so I get to use a solid line. Okay, and then we graphed it. Great, good for us. Sadly, that's not the entire solution. So that's the solution, y equals negative 3x minus 2. But our inequality says greater than or equal to that. So we get to shade the region above that line as well. So we're going to shade above that line. Now, you can take your time and do good shading. Or you can do this fast, crappy shading like I'm doing, and it's completely fine. No one cares. You do not need to spend 5 years shading just so. Yes, dear.
So why are we shading that above?
Because it's greater than. So greater than, we're going to shade above the line. Less than, we're going to shade below the line. And that kind of makes sense. Greater than, above the line, less than, below the line. That makes sense. But when you start questioning your sanity, because trust me, we all do. It happens. You're like, did I really shade the right region? So there is a way to check yourself to see if you shaded the right region. You can pick what I'm going to call a test point. Now, I like to pick a test point somewhere in my shaded region. For instance, I see 0 zeros in my shaded region. So I think it would be really smart of me to plug in 0, 0. So literally, our equation was y is greater than or equal to negative 3x minus 2. I'm going to plug in a 0 for x. I'm going to plug in a 0 for y. And I'm going to see what happens. If I plug in a 0 for y, 0 for x, I end up with 0 is greater than or equal to negative 2. Is that a true statement? Is 0 greater than or equal to negative 2? Yeah, that's a true statement. So we shaded correctly. So when I plug in my test point, I like to pick one from my shaded region. And all I'm doing is I'm checking my own sanity. If you reach a true statement at the end, you did shade correctly. If you end up with something crazy at the end, like negative 5 is greater than 10, you shaded incorrectly. You need to rethink and reevaluate your life. Now, do you always have to plug in a test point? No. But again, if Jax is questioning, did I really shade correctly? It's not a bad idea. Okay, are there any questions about number 1? Let's go to number 2. Can someone tell me how to graph number 2? Yes, dear. Okay, so it was y equals x minus 5. So our b is negative 5. Perfect. 1, 2, 3, 4, 5. Now what? I counted 1, 2, 3, 4, 5. Yeah, I did. Okay, good. Now what? Okay, perfect. Thank you, dear. And your group can get a point for that. And now there's a super easy point available from here. Dotted or dashed. And Nick said it first. So we're going to do we're not going to do a solid line. We're going to make it kind of a hot mess of a line. And that makes it, when we use this dotted or dashed line or whatever you want to call it, not spilling it in all the way, that lets a math teacher know or whoever know that your given problem wasn't less than or equal to. It lets them know it was just a less than. Because what you're really saying is this dotted line is showing you where to look, but that dotted line is not part of the solution set. Okay, and since it's less than, we assume we should shade below. Yeah, I saw you. You can have a point for that. So we assume we should shade below. Oh my gosh, I just did Auburn colors. Who am I? Okay, so, and that is the correct assumption. But if you're still questioning your own sanity of, should I have really shaded there? Pick a point somewhere in that shaded region and let's test it. So for instance, it looks like 7, 0 is in that shaded region. So for my test point, I might use 7, 0. So my equation was y is less than x minus 5. I plug in 7 for x. I plug in 0 for y. Is 0 less than 2? Yeah, 0 is less than 2, so we did shade correctly. Okay, I'm not necessarily going to plug in a test point from here on out. I can if we need to. But I am going to say something that Miss Brister, who's with me first period, she does differently than me, and it's not a bad idea. I always pick a test point. I pick it somewhere in my shaded region, then I select it. She always plugs in 0, 0. No matter what, she does 0, 0. No matter what. So she expects, like on our first problem, let me see if I can zoom on both. Like on our first problem, since 0, 0 was in our shaded region, she knew she would reach a true statement. But on our second problem, since 0, 0 wasn't in our shaded region, she knew she should get something crazy, like negative 5 is less than, like negative 5 is greater than 10. She knew she would get something crazy. So and that's not a bad idea. If you're understanding that shouldn't be part of the solution set, I should get something crazy that's not true, then always go with 0, 0 and it makes your life easy. It's not a bad idea. But that's not how I do it. So you can do whatever you want. When we get to number 3 in life, it's more complicated. Why? Yes. Yes, ma'am. And then help me fix it, Paige. Get a point for that, Ellie, and help me fix it, Paige.
Subtract 2y.
Subtract 2y?
You make it 2y equals.
Yeah, I subtracted x.
Okay, we want to get y all by itself because we want it in y equals mx plus b, so we can graph it like usual. Paige knows that. She's trying to make life complicated. She's not going to, though. We're not going to let her. Okay, so we've got 2y is greater than negative x plus 6. Now what, Nick? Now we can divide by 2, and we end up with y is greater than,
Negative x over 2.
which is the same as negative 1/2 x, and then what? Plus what? Plus 3. Okay, so if we end up with something that, in what form, ooh, this is a good question, I didn't think of that earlier. What form was number 3 in? And your group gets a point for that. It was in standard form, and we had to rearrange it into slope-intercept. He said it first. There were others who said it, but he had it out first. Okay, so we rearranged it to slope-intercept just because that helps us graph. We put our point at 3. Our slope is negative 1/2, so down 1 over 2, down 1 over 2, down 1 over 2. Okay, and then the easiest question, ooh, I can do it, no I can't. Easiest question, what do I do from here? Ooh, she wants to shade above, which is good, and she can have a point for that, but what else do I need to do? Dotted line, Jack, thank you. So we've got to make this a dotted line because it's just greater than, not greater than or equal to. Now, Paige is correct, and we assume greater than means shade above, so we seriously shade it up here. And I'm not going to, but if Paige is questioning sanity, this would be a good time to choose a test point and test it out. Or you could choose 0, 0. You know you should reach a false statement, in which case you would be correct with your shading. Up to you. Are there any questions about 1, 2, or 3? Okay, we have a couple left. We gotta make life a little more complicated. And bless my heart, you know I can't make things happen with stapling and everything. You knew I was gonna mess up something. So our next problem is not this absolute value one. Sorry guys, we're doing inequalities. That is not an inequality. Our next problem is actually number 4, and it says x is greater than or equal to 6. It might either be on the front of your last page or on the very back of your last page. I know I stink. You don't have to tell me. I'm aware. I gave you all the things at once. We knew something was going to go wrong. Okay, to get your group 8 points, number 4 says x is greater than or equal to 6. Can you hold up your arm for what that graph would look like so your group can get a point?
Am I wrong? Wait, actually it would be this.
Daniel's group gets a point. Okay. Other groups eventually figured it out and changed it. Y, the y-axis, when we say y equals 6 would be that, yes. X equals 6, remember we discussed it wasn't a function. It goes straight up and down. You had x equals 5 on the last test. So we're actually going to go on the x-axis over to 6. 1, 2, 3, 4, 5, 6. And it makes sense that since we've got to hit the 6, it's got to be a line like this. How else can you hit 6 on the x-axis? How would you hit it if it was a line like this? You wouldn't. You would hit y equals 6, not x equals 6. Okay, and then I've already cheated because I already filled in my line because I realized the problem was a greater than or equal to, so I knew I could go ahead and fill that in. And then now for the shading. So it's supposed to be greater than or equal to. Do you think greater than is the right side or the left side? It makes sense that it's the right side. But again, when it's like this, I'm kind of with Angel where I start questioning my sanity. So for sure on this one, I would do a test point. I'm going to pick the point. I don't know why I'm into 7-0 today, but I'm going to pick 7-0 again. And so if I plug in 7 for x, is 7 greater than or equal to 6? Well, yeah, that's a true statement. But like I said, Miss Brister does life differently. She always plugs in 0, 0. She realizes that's not part of our shaded region, so this test should fail. So when she writes 0 is greater than or equal to 6, she's like, no, that's not true. She's happy because it was supposed to fail. That's why we didn't shade it there. So you got some options when you're thinking about your test points. Okay, and then now we're going to make life super annoying with 5 and 6 for 2 points, not Daniel. I feel like Daniel knows this one, so not Daniel. 2 points. How can we make inequality problems harder? What could we do to complicate your life with this inequality?
Leave it in that form.
Jax. We could keep it in standard form and have to rearrange, but we already did one like that. I'm saying this is even harder than that. What could we do to make our life even more complicated with an inequality? It's something that only you do with an inequality problem. Do you know the answer? Okay. You think you do? Yes, dear. And his group gets 2 points. Okay, so I'm going to remind you of something maybe you forgot. But if you multiply or divide by a negative, you have to flip the sign. Okay, for other reasons, we just did inequalities in discrete. And they got super into flipping the sign. Like I had this person who on their test, every single problem, flip, 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 flip. You cannot always flip the sign. The only time we flip the sign is when we multiply or divide by a negative. And so in 5 and 6, clearly that's what's going to happen to us. We're going to end up multiplying or dividing by a negative. So again, you're right, it is in standard form. So my first step would be to subtract 4x. So I've got negative 3y greater than negative 4x plus 12. But when I divide by negative 3, life gets complicated. Here is our issue. When I divide by negative 3, life gets complicated. Yes, it is y. Yes, it is 4/3 x minus 4. But since we divided by a negative, we need to flip that sign. So instead of a greater than, we would have a less than. Let's say that again. Since we divided by a negative, we have to flip the sign. So we went from greater than to less than. And you're like, Miss Kaufman, that's not going to make much of a difference. And after we graph it, we'll talk about why it does. Are there any questions about this? Okay, well then let's graph it. Let's go down to -4. -1, 2, 3, 4. Up 4, 1, 2, 3, 4 over 3, 1, 2, 3. Up 4, 1, 2, 3, 4 over 3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. I'm out of room. Okay, help me with the easy part of this. It's a dotted line, Nick. You get a point. Dotted line because it's just a less than. Okay, so we've graphed our line. Now we need to decide where to shade. Where will we shade? Yes, dear. We're going to shade the bottom because it's less than. So we're going to shade underneath the line. Perfect, Jack. You can have a point for that. Now, if Jack had not flipped his inequality, if he had left it as greater than and hadn't swapped it to less than, wouldn't he have shaded above rather than below? So you can see how suddenly your whole answer is messed up because instead of shading underneath the line, you shaded above the line, and that changes everything. Or if Daniel makes the mistake of prematurely flipping, he's still going to run into this same scenario of he shaded the wrong region. He's probably graphed the correct line, but the whole solution set, good grief. That was almost a bad word. The whole solution set, good grief, is where you shade. So if you're shading incorrectly, you've missed the solution. You missed it. That thing, you missed it. Can't, it's not coming out. Not in a positive way, that is for sure. Okay, number 6. Whew. If your group needs points, this would be your chance. Can you help me rearrange this equation into y equals mx plus b? Yes. Okay. We're going to subtract 6x from both sides. Okay, so we'll have 4y less than or equal to -6x minus 24.
And then we divide by 4.
We divide by 4. So what do we end up with? And then what? Okay, table 1, you get your point. So does 2 and 5 because they help to simplify. Okay, and then lo and behold, I tricked. Did we divide by a negative? No. So did we flip the sign? No. Now, some people are going to want to flip the sign because there were negatives involved to the right, weren't there? There were. So you were like, should I flip the sign? But if you're not dividing on both sides by a negative number, do not flip the sign. So we need to go to -6. 1, 2, 3, 4, 5, 6. I'm telling you, some people are going to flip prematurely. It's going to break my heart. Up 3 over 2. Up 3 over 2. Up 3 over 2. Over 2. Down 3. Right 2. Okay, if they less than or equal to, so you go ahead, Jax. It's a solid line. Thank you. You can have a point for that. Someone else try. Go ahead, Jax. You shade below because it's less than. But again, if you flip prematurely, you would have shaded above. Then you would have gotten the wrong solution set. Okay, are there any questions about this? Life seems pretty good, right? Okay, the good news is there is no page for you to do for homework on this. The bad news is there is a checkpoint. Good news is it's only one question. Bad news is I'm a little slow today, so I just need you to bring it and put it on my desk when you get done. It's going to take me a hot minute before I actually look at it. When you finish your checkpoint, since I don't have any other set math that you must do today, I would genuinely appreciate, and probably you would get your group some points, if you could. There's no need for you to do